for our properties, we're going to be talking about algebraic properties of equality. If you were to solve this equation, what would you do? You would add 5 to both sides, right? Now, when you remember back in algebra, why do I need to add 5 to both sides?
You have to get the x divided to the other side.
But why does it need, remember you guys, we had to talk about it being balanced. Like you have balance bar, so what I do to one side it has to do to the other side. So what I did is the addition property of equality. So please write the following. So if you're given x minus 5 equals 10, if you use the addition property of equality by adding 5 to both sides, then your conclusion is x equals 15.
As long as I stay away from substitution, I'll be glad. I hated that property.
It's not too bad. So what do you think it would look like for subtraction? If what, then what?
You would subtract 5 from both sides.
Well, what does the operation need to be here to subtract 5? Add. So if x plus 5 equals 10, then x would equal 5. So if we think about the word inverse, the inverse of subtracting 5 is adding. The inverse of adding 5 is subtracting 5. So what's the inverse of multiplication? Division. So multiplication property, let's go back, would be if you had something x divided by 5 equals 6, then x would equal 30. Yes.
Yes.
Division, if 2x equals 10, then x is equal to 5. So you would use the division property to solve for x, because it's 2 times x. The inverse of 2 times x would be to divide by x. So these are pretty easy to work with because you're just kind of doing the operation that you state the operation that you're doing and throw the word property after it. Now, if I were to check my work and substitute 15 into here, does 15 minus 5 equal 10?
Yes.
We know we did it right. If I substitute 5 in for x here, 5 plus 5, does that equal 10?
Yes.
If I substitute 30 in, 30 divided by 5 is 6. If I substitute 5 in for x, 2 times 5 is 10.
Yes.
So what are we doing when we do the substitution property?
You substitute the answer from. No. Am I
Keep
on
talking.
the right
Yeah,
track?
keep talking.
If you substitute the answer in a given problem with the number with the x, then you would get the real answer.
Right. So right now I'm saying 5 is equal to what?
X.
X. Well, if I have an x here, what the substitution property says is if 5 is equal to x, then it still stays true that instead of x, we can substitute in the number 5. So this is how we're going to write it. For substitution property, if x equals y, comma, then y can replace x in any expression. All right, so we're going to use these properties to complete a proof. In geometry, there's a whole bunch of proofs. In this class, we're just going to focus on 2-column proofs. There's something called paragraph proofs, and there's something called a flow proof. We're just going to focus on 2-column proofs in this course. So we have an example of a 2-column proof right here given to us. The left side is already filled in, so we need to come up with the right side. So again, 2 columns, column 1, column 2, hence why it's called a 2-column proof. You make your T-chart, you label the left and the right. So we have the equation 3x plus 8 equals negative 4x minus 34. We want to write the reason for each step. Did anything happen here from the original equation? No. So whenever you have the first start, you always write out with the word given, because that's given to us. The equation is given. All right, so now let's look to see what changed from line 1 to line 2. What did they do?
Added in a positive 4.
They added positive 4x to both sides. Since we added 4x to both sides, what property do you think that is?
Probably.
Substitution?
We added
Addition.
addition, good. So addition, prop, I'm going to put prop for property of equality. I'm going to abbreviate equality with just an equal and a period. Okay, so then what happened from line 2 to line 3?
A lot. No, I'm just kidding.
Well, what did we go from here to here?
Combine like terms.
Combine like terms, combine like terms. Whenever anything happens like combining like terms, we just use a generic word of simplify. So this was simplified. So I'm just going to write simplify.
Or simplified.
Right. All right. What happened from line 3 to line 4? What are they doing?
Added in a negative 8 or subtracted a negative
So
8.
which property?
Subtraction.
Good. So this would be the subtraction prop of equality.
That's a good one.
Okay, then what happened?
Combine like terms.
So another
Simplify.
simplify.
That wasn't
Okay,
even
guys,
me. That
stop.
wasn't even me.
And then what's the last move?
Divided.
So which property?
Division.
Yeah. Now, as you get good with this, you should be able to get rid of most of the simplify lines. Like when we go to do the one on the back, instead of showing this step, I could have just jumped from this line to this line and said addition property. And then jump from this line to this line and said subtraction property. And then to division property. So you can write less. All right, so we've got one more property we need to discuss that's on the bottom of your page. That's the distributive property, everyone's favorite. Remember, the distributive property states if you have some number, so if A is times some quantity of something, in this case B plus C, then you distribute that A to get AB plus AC. Good old distributive property, everyone's favorite. All right, so flip on to the back. Now, I know there is not a whole lot of room, so you're going to want to practice writing small. You need to do at least 4 or 5 lines for this next example. Let's go ahead and set up a T-chart. So whenever you're asked to justify your steps or provide a proof, first instinct should be to make a T-chart. We're going to write statements on the left, reasons on the right, and you always start out with your given. Yeah, I need to give you a pass. So we have 60 is equal to negative 3 times 8x minus 4, and that is given. Now it's up to you. You can break them apart by lines if you want, or if you want to organize it by saying line 1, that's up to you. Whatever you think would work best to keep yourself organized. But you should have some kind of system for breaking apart your steps. Okay? All right, so if that was your equation, what would be your first thing you would do?
I personally would
Multiply.
I like that idea. Let's do that. So let's distribute that negative 3 to 8x to get negative 24x. And then a positive 12. So what am I going to write for my reason on the right side?
Distributive property.
Good. Distributive property. Okay. What will be your next move? subtract 12. Now, if you want to do less writing, and you can mentally subtract 12 from both sides and get 60 minus 12 is 48, you can jump to that. 60 minus 12 is 48. Did I say, what did I say?
You said 60 and it confused
Oh.
me. But
Sometimes what I like to do is I like to put a little tiny little minus 12 there to help me think about what it is that I'm doing. If you want to do that, you're fine. So then we get 48 is equal to negative 24x. What property just happened?
Subtraction.
Yep. Subtraction property.
So you don't have to do of.
Yeah, I guess we should. I just thought of that. Of equality. Of equality. Last move.
Divide.
Divide. So 48 divided by negative 24. Negative 2 is equal to x. Division property of equality. Done and done. Okay. Questions with any of that? Yeah. Yeah. All right, so we're going to pause here. Room.
my arm is going to fall off.
So, all we're going to add now, we're still going to be doing the algebraic proofs, but now we're just going to add a geometric part to the proof before we get to the actual algebraic part. So, start with your T-chart, statements on the left, reasons on the right. We should always start with what? The given. As we move on in these proofs, there should never be a blank proof. You should always have the given. The given is the measure of angle AOC equals 139 degrees. Given. Because it says given. Did everybody see that? Okay. All right, so what did we do? I needed to solve for x.
43.
We need to prove it. We need to justify each step. What did we do first? For substitute, we have to come up with the angle addition statement. Okay? When you're dealing with anything with angles or line segments, you have to do the actual letters before you get to the numbers. So we're going to write out the angle addition statement, which tells us that the measure of angle AOC is equal to the measure of angle BOC plus the measure of angle AOB. What would be my reason on this side?
Angle addition.
Angle addition. Postulate. I am not going to be so picky if you remember that it's a postulate. If you just write property, I'll be happy. But you should try to remember that it's postulate. Okay. So now that I have my angle addition statement, now we can substitute in the actual measures of everything we wrote there. Well, what is the measure of angle AOC? 139 equals the measure of BOC, 2x plus 10. The measure of angle AOB is x. Which property did we just do? Substitution. Substitution. Prop of equality. Okay. What did Anna say our next move was going to be? Simplify.
Oh, I'm tired.
Thank you for sharing with the whole world. You can keep that to yourself.
Alright, I will.
139 is equal to 3x plus 10. Next move. Subtraction. 129 equals 3x. Oops. subtraction prop of equality. I know there isn't a lot of space. I was just trying to not make you have multiple sheets. Last move, division, 43. Division prop of equality. Now, you don't have to put this in your notes. What if I add it to this problem? Given that the measure of angle AOC is 139 degrees, I want you to prove that the measure of angle BOC is equal to, what would that be, 43 double 80, 96 degrees. What lines would I need to add to my proof to prove that the measure of angle BOC is equal to 96?
Plug it in.
Well, what did we say the measure of angle BOC is?
43.
What was the expression for BOC?
M equal
BOC is
2x plus 10.
2x plus 10. What am I going to substitute in place of x?
43.
So I could rewrite this as 2 times 43 plus 10. What property did we just do there? Substitution. So substitution, prop of equality. And then what would be our last move?
Simplify.
A simplify, good. Addition property would only work, Seth, I'm glad that you said that. Addition only works when you add on both sides of the equal sign. Yeah, so we're just simplifying. So the measure of angle BOC would equal 96 degrees. Okay, so I'm going to have you